Shalom Habarim. Welcome, friends, guests, visitors, family members. Just on the Sabbath here. Sabbath peace, y'all. Now, the thing is, still got some ideas that are permissible to document and share at this point. Now, for the best standard practices and procedures, we shall in fact become clearly cognizant of and realize and comprehend what our actual real-time position within the cycles of life is as part of and as it is important in order to accomplish self-mastery and to even master our lives and our destiny in a good way in accordance with God's will. So right now, it's a Friday evening at 7:51 p.m., the 15th of August, 2025, on a Friday evening, and we have a neutral short lunar unit for another 2 hours and like 18 minutes. And then after that, it's a 3-hour positive short lunar unit because there's a tide in 5 hours and 18 minutes that's high, the nearest maritime port. And so also, we are currently in a 3.5-day positive long lunar unit till, see, there's the divine guidance and correction and protection there and instruction. It's actually that, so the 3.5-day lunar unit, the 3.5-day long lunar unit to be precise, this is, let's see. It's very close to becoming negative again, and it's possibly positive right now. The reason I say that way is because of the following. Shall we explain this? Yes, it's worth it, and you should know this too. This is about having absolute accuracy within your wise, safe, and prosperous navigation of the cycles of life that you're in. So just for a second here, subject matter, lunar units of the cycles of life, right? You've got a 3-hour short lunar unit, and then you've got a long one of 3.5 days, always basically alternating between negative and positive, right? Now, say, starting on the date of the new moon, the date, time, day, hour, minute, etc., you can basically see on the exact time of the new moon, right? Start there. One is coming up on the 23rd of August. Be prepared. Here's how, right? And here's how to win, yeah? So, on the exact date and moment of the new moon, you have a 3.5-day negative long lunar unit right after the new moon for 3.5 days, right? 3 days and half a day after the exact time, date, and minute of the new moon, right? It gets preciser, though, that should suffice. You've got a 3.5-day negative long lunar unit. And then 3.5 days after a new moon, you've got a 3.5-day positive long lunar unit. And then you've got a negative and a positive, and, after an even amount of that, you've got a full moon, And then 3.5 days before a full moon, you've got a positive long lunar unit again. And then 3.5 days after a new moon, a negative one. It just goes on and on like that. See, there's a very interesting thing. I'm still trying to figure that out. And I've even written to NASA and others about this because there's got to be a way to pinpoint this. So here's the thing. If we mark down the time and the date, of the new moon on our calendar, okay, and then we use that time and date and reference moment so we got the time and the date of the new moon on the calendar. We use that as a reference point and we mark off 3.5 days after that so we can identify the negative 3.5 day long lunar unit. And then after that 3.5 days after the new moon, we mark off another 3.5 days exactly, right? So we can identify the following positive long lunar unit. And you do this a couple of times or more till finally you arrive at the point where you see that, for example, the next full moon is coming up. And so based on the exact time and date of the next full moon, right, the day, the hour, the minute, etc., you then mark off 3.5 days before that so you can identify that final positive long lunar unit of 3.5 days before a full moon. Well, then what happens is that, see, the date and the time of the new moon as a reference point, if you use that, right, and you keep marking off 3.5 day units after the date of the new moon till the date of the next full moon, right, what happens is there's a discrepancy that occurs in there. And I've tried to figure out how to fix this. I've talked to those who are, intelligent. And so what happens is right about now, like, let's say sort of in the middle of the lunar month. Is that correct? Actually, so right about now, for example, we had a full moon on the 9th of August. Today it's the 15th, and we have a new one on the 23rd. Okay. So right about now, what's happening is that if we are going to, and we would like to, and we should be able to exactly identify the lunar long units that we're in terms of whether they're positive or negative. So then what happens is the farther away we get from, since the new moon, the closer we get to the next full one, you start to sort of move the point of orientation over from the date and time of the new moon to the date and time of the full moon, to use that as an ending point or a starting point to reference and to map out and to calculate 3.5 days in terms of the lunar units that are long of 3.5 days. So what I'm saying is there's a problem if you on the new moon at the beginning of the lunar cycle of from new to full, whatever that's called again. So you mark off 3.5 days, that's negative. Then it's positive, then it's negative, then it's positive. And so you arrive at the coming time and date of the full moon, and then that no longer is accurate because you see then using the new moon time and date as a reference point to systematically mark off 3.5 days over and over and over till the next time of the full moon, it doesn't work out because the date and time of the full moon, if you mark off 3.5 days before that, it shows you a different information. Now, I was told this is because the lunar calendar, the lunar month is different than the one we have here in terms of calculation or something, but we still have to be able to accurately identify this. Okay, listen, picture this in your head for a second, right? You have got a long horizontal line with a small vertical line at the end at the beginning and a small vertical line at the end at the end of it. Left, right at the beginning of this long line with a little mark like this over here, and then there's a little mark again. Got the new moon here, 3.5 days, right? Negative. 3.5 days positive. 3.5 days negative. 3.5 days positive. And finally, till the full moon is over here, and 3.5 days before that, right? Right here, before that full moon, 3.5 days, it's positive. It's a positive long lunar unit. But see, if we use the new moon time and date as a reference point to mark that out till the next full moon, the data doesn't work. It doesn't work right. So then I have to go in like this time of approximately this time of the this time of the month where we're just in, for example, we're just in between, we're assuming like almost halfway between a new moon and a full moon, or when you're about almost halfway between a full moon and a new moon, right in the middle there's kind of this overlapping of information. And so then the closer we get to the next full moon, the more you start to sort of, I guess, use the data of the date and time of the full moon to mark out 3.5 days from before when it happens, and then from before those 3.5 days, so that you're accurate. But there's this discrepancy going on. And how can that be going on? It doesn't work. It's impossible. There has to be a way to map this right. And what I'm figuring out is that we have to look at the lunar. Because look, the moon too has definite orderly cycles. And if it's like, there's a general rule that starting on the date and time of the new moon, 3.5 days after the new moon, it's a negative long lunar unit. Then it's a 3.5 day positive long lunar unit. Then it's a 3.5 day negative long lunar unit. And then it's a 3.5 day positive long lunar unit. And, 3.5 days before the full moon, it's a 3.5 day long positive lunar unit again. So there has to be a way to accurately mark this out. And so then what I figured out is that it has to do with the fact that the moon has a different, so there's a difference between see, if I'm measuring, it doesn't matter. Like if it has a different, what is that called? Like a time zone almost, in terms of the, so a lunar month is shorter than an Earth month or something like that. That's that type of stuff. Yet it doesn't matter if I'm measuring, God damn it. Look, if I'm measuring, okay, it's almost like this. Trees are taller than corn stalks. But it doesn't matter if I'm measuring the height of a corn stalk or a tree. If I'm using a measuring unit, a unit of measurement, like, for example, meters, then I'm measuring this stuff in meters, and that's how it's going to come out, and it's going to come out evenly. So it's going to be like systematically correct. So it's really strange. Why isn't it possible to just get this thing figured out exactly? Maybe someone will see this video and please send a response here and inform us of how to fix this, because I've been trying to fix this for a while. And what it actually is that, so like, I think I've explained basically so let's start at the new, right? Between the time and date of the new moon and between the time and the date of the full moon, right? In between all of that, there are equal 3.5 day long lunar negative and positive units that are to be identified on a calendar. And if you use the time and the date of the new moon to start to mark off 3.5 days and another 3.5 days and so on, by the time you get up to you get close to the next full moon, right? On the other end, on the other side of the equation, it doesn't come out in even 3.5 day long negative or positive units anymore, and you have to use the reference point of the next full moon in order to logically and truthfully calculate and identify 3.5. First of all, the 3.5 day positive long lunar unit, 3.5 days before the full moon itself, and then before that, the 3.5 day long negative lunar unit before that one. So it's like there's an overlapping and a discrepancy in the middle there. And I've been trying to figure out why that is the case. And it just has to be possible. I think I know why. Because the lunar, it has to do with the lunar day or the lunar month being a little bit shorter than the Earth days and lunar months and Earth months or something like that. And so therefore what happens is you have like but see, if I have it doesn't matter it's almost like it doesn't matter what language it's in. If I've got a time and a point in time identified and another one identified, that's the same time and point in linear time, whether it's here or there, right? It's like, it doesn't make sense. I would like to be able to repair this. So somebody who's like a scientist or something, please send me a message, and I can provide further details. It's really actually very simple. It's something I've been trying to fix for a while, and it doesn't. I guess it has to do with the difference in time, or like a lunar day versus an Earth day, and a lunar month versus an Earth month, or something like that. But see, yet the thing is, the time and the dates of the actual new moon and the full moon, they're clearly identifiable and identified to us here in Earth time units. And so how come I can't accurately get 3.5 days marked off systematically between the new moon and the full moon equally from the date of the new moon to the date of the full moon, so that I can see the alternating negative and positive long lunar units there? We're looking at what we're trying to do, right, is, so it's so strange. I wonder why it's like that. It can only be the case that there's a time span, there's a time frame between the new moon and the full moon is like of a certain length. But see, it just doesn't matter. It has to come out accurately and evenly, when evenly divided into 3.5 day segments. So what we're doing is we're dividing and setting up and marking off equal 3.5 day segments from the date of the new moon to the full moon, so that we can see when there is equally long, either negative or positive long lunar units of 3.5 days between the date of the new and the full moon. There has to be a way to do this right. Okay, I'm going to end this now.